Here's lesson 2, chord properties. So we start off with some definitions. The chord of a circle is a line segment which joins 2 points on a circle. So that could be, this point and that point is joined, that point and that point is joined. Any 2 points on a circle, that's a chord. A diameter is a little bit of a special chord in that it goes through the center of the circle. So diameter goes through the center of a circle, and the radius is half of the diameter. So let's label some stuff here. So this is just a plain old chord. This is a radius. And the entire thing here is the diameter. Now the diameter is equal to 2 times the radius, or the radius is the diameter divided by 2. Here's another definition, a perpendicular bisector. So perpendicular means 90 degrees, and bisector means to divide in half. So here's the theory. The perpendicular bisector of a chord contains the center of a circle. So we are going to say that if this diameter, so this chord here, this perpendicular bisector is going to cut this chord in half. So this is equal to this, and it meets it at 90 degrees. Okay, you need to note that these two sides are equal length. So the theory, the perpendicular bisector of a chord contains the center of a circle. So that means if you just have a chord, I won't put the chord in the same position actually, let's do a different chord. So if we have some chord and we find the center of that chord and we draw a perpendicular line to it at 90 degrees, it's going to go through eventually the center of that circle. That's what that means. So let's use this theory to solve some problems here. So find the length of AB. Now AB goes all the way across, okay, round to the nearest tenth. Well, the theory we just said is if we have the center of the circle and it meets a chord at 90 degrees, that means that this side is equal to this side. So if that side is equal to that side, this is also 3. So the entire length is 3 plus 3, 6. There's no units. So this entire thing is 6 units. Here's another one. We need to figure out the length from A to B. All right. So we've got that this is 12, that's 8, that's meeting this at a 90-degree angle. Now there's one thing to note here, that this is a radius. Now a radius is the same distance from the center outwards in every direction. It doesn't matter which point of the circle I'm drawing, they're all going to be 12. So that's very unique in that we can just kind of swing this radius around and create a triangle here. So this is also 12 and this is 8. So really we have a right angle triangle that has a hypotenuse of 12 and a side length of 8, and we need the shorter side. So we're going to do 12 squared minus 8 squared is equal to, we'll call it a squared, the shorter side. Okay, so 12 squared minus 8 squared, that's 144. Minus 64 is a squared. So a squared is equal to, just double check my math, 80. Take the square root of that, and a is equal to 8.944. Okay, so this length from here to here is 8.944. And since they're equal, we can just double that. So 8.944 times 2 equals 17.8 if we round 89. So the entire distance here is 17.89. Okay, here's one more thing. So we're looking for A to B. So that's here to here. Okay, now if this is 20, this dimension here is also 20 because it's a radius. So we have this little right angle triangle, 20 and 12. we have the hypotenuse, we have C, we have A, we're looking for B. So C squared minus A squared equals B squared. So we get 20 squared minus 12 squared is equal to B squared. 400 minus 144. So 256. And don't forget, we're taking the square root. So that's 16. So the length from there to there is 16. One more example here. Okay, a hemispherical pot is used for a hanging basket. The width of the surface of the soil is 30 centimeters. So the entire thing, this 30 centimeters is the entire distance across, which means that this is 15 and this is also 15. Find the radius of the pot. So if this is 15 and the height here is 10, we're creating this scenario. It's not quite drawn to scale. Okay, so that this is 10 and this is 15, and it's a right angle triangle. So 10 squared plus 15 squared is equal to C squared. So 15 squared plus 10 squared is 325. Take the square root, and we get 18.02. So if we're rounding it to the nearest tenth, that's 18.0 will be the radius. A couple PAT questions here. The arch in the diagram forms a complete half circle. The black support beam in the diagram is 3.6. All right, so let's label that in there, that this is 3.6, and is 3 meters above the surface of the water. All right, so this is 3 meters, and that whole thing is 3.6. What's the diameter of the arch? Okay, so if we were to complete this thing, we're looking for the diameter which goes straight across. If we find the radius, so from here to here, we can double it to get the diameter. So we've got this little thing here. The entire distance is 3.6. So if we cut that in half, that's going to be 1.8. And we said the height is 3. So we're looking for C, which is the hypotenuse. So 1.8 squared plus 3 squared equals C squared. So 12.24 is equal to C squared if we take the square root. C, or the radius in this case, is 3.5. So that's halfway across the circle. So 3.5 times 2 is going to give us 7 meters. So what that means is this part's 3.5 and that part's 3.5. So together the whole distance is 7. Here's another one. A diagram of a swimming pool shown below. The dotted circle represents floating buoys. The pool has a diameter of 10 meters. So the diameter of 10 meters, so all the way across is 10, which means that halfway, or the radius, is going to be 5. And if this is a perpendicular bisector, this part is 3, and that part's 3. So we've got 3 here, got 5 here, and we'll complete our right angle triangle looking for this part. So the shortest distance from the buoys to the edge of the pool. Okay, so if we find out this portion, and the entire thing's 5, we can do 5 minus the portion that we get. So that unknown is going to equal the final answer. Okay, so 5 goes all the way across. We're going to find a portion of it and then subtract the portion from the entire distance. So 5 squared minus 3 squared equals, call it A squared. 25 minus 9, that's 16, which means that A is 4. So this portion is 4, and the whole distance is 5. So 5 minus 4, it's 1 meter distance here.